I'm going to do this problem two ways. I'll do it the way that I taught it in the lecture and the way that I think is easiest to comprehend for many of my students who want to understand what they're doing. That doesn't mean you have to do it that way. You can also do it the way that it shows up on the video for the homework. I'll know that you did it that way, and to be honest, in a way I'll have some doubts as to whether or not you fully comprehend what's going on, but maybe you do, so I won't judge fully. But the fact is there are two ways to get it and they get the same answer. So I will show both ways and you can use either one of them to get it done. First one I'm going to look at, I'm going to do the morning and the night. That's the way I do it. I say, look, here's what's going on. There are 3,000 people and they all buy tickets in the morning. So every one of the 3,000 over 3,000, you can even call that one if you want, but that's what's going on. 3,000 people buy tickets out of 3,000 people. Okay. Now, we're going to have to multiply that by how their morning goes for their wallet. And that is that they are buying a ticket for $4 each, so that means that they're going to lose $4. That means in the morning, each, now maybe people buy more than one ticket, that's okay. There are 3,000 purchases of a ticket, 3,000 of them here. Each one is $4. So how many tickets you buy costs you $4 each, and in the morning, you lose $4 for each ticket that you buy, and it's gone. All right, that money is gone forever. Don't worry about it. Plus, you come back in the evening where one of the 3,000 tickets is going to let someone walk away with $750. So this is 1 times -4 as dollars go. Plus, this is $750 over 3,000. What are those as decimals? That's -$4. What's this? Positive 25 cents. And your expected value of the ticket is to lose $3.75. What actually happens is if you do them as separate events, you lose $4 when you buy a ticket in the morning, and you win a quarter when you come back, but you don't actually see that quarter as that coin. You have that little piece of the prize that is your expectation as a decimal. You may be the one person that wins the $750, that contributes to the decimal, or you may be one of 2,999 people who does not, which does not contribute to the win. They just don't lose anything. They already lost in the morning, they lost nothing. It was like a free roll when they came back at night for the drawing. That's the way I do it. Here's the other way to do it, the way you'll see it in the book, and you're welcome to do it this way if you want. They say, here's what goes on. We have 2,999 people out of 3,000 who for the day lose $4. Plus, we have one person out of 3,000 who for the day gets $750 in the evening minus the $4 of their own money that they spent in the morning. And so now this is going to get them 2,999 times 4 with a negative and a dollar sign. That's over 3,000. Plus, this is going to get them positively 1 times 750 minus 4, which is $746 over 3,000. So the 3,000s are the same, so we can make a common denominator. And this is $2,999 times 4. So that is a loss of $11,996. Use your calculator, of course. And this is a win of $746. So we add those together and we do the subtraction. We subtract off 746 from this to see what the difference is. That leaves you 250 behind the 11,000. So you got negative $11,250 divided by 3,000. And if you do that, you'll find that you get negative $3.75. Feel free. They both work perfectly fine. Is there anything good about this? Well, some people freak out if you don't have that being, these two fractions add up to 1, because now you're saying this is the probability that that is the delivered amount for the person at the end of the day, is the probability that that's the amount delivered for the win for that person at the end of the day. In this case, I look at the event, what's the expected value of what happens to any person working in the morning, what's the expected value of each person that shows up in the afternoon, and you wind up with the same value. It's definitely not a good value. You shouldn't buy every ticket you can because you think you're going to make money. It is a negative expected value. But what you're doing is pretty much you're giving the $4 to the charity each time you buy a ticket. You get a small chance to win some money back at the end that has a positive impact on the expected value. This one views it more like, oh, I'm a loser if I'm one of those 2,999 people, and there's one winner. There's one winner either way, but here everybody takes a full loss in the morning and one person gets the windfall in the afternoon. But everyone comes to their not feeling like they're losing. They feel like they're getting a free shot at that $750. In this case, it's more like, I hope I'm not one of those multiple thousands of losers and then I'm the one winner. So, you know, the numbers say the same thing, so they both tell the truth. It's not a good bet, but you're giving money to charity, and that's fine. We have one more problem to look at here in homework 4. So this question is about where you have just gotten a $4,000 tax refund. That's how the question is phrased in the homework. You shouldn't really treat that money any differently, but that's going to come later in the course that we talk about what tax refunds mean and all that. Let's say you have $4,000 to invest. You can invest it in the Easy Company with a 20% chance to make $1,200, a 20% chance to make $300, and a 60% chance to lose $2,000. You'll still have $2,000 left if that worst case comes up. And then there's Jackson Builders. You have a 90% chance that you'll make $3,000 and a 10% chance that you'll actually lose the whole $4,000. We want to decide which is a better investment. This is strictly based on EV. Then I'll ask you a couple questions to just ponder about what you'd actually do, and maybe you wouldn't invest in these at all. Let's go with Easy first. What they have you doing is you've got a 0.2 chance of making $1,200. Nice. Plus a 0.2 chance of making $300, which is okay, should be losing. Plus a 0.6 opportunity that you lose $2,000. So we'll see what that is. 1/5 of that is that's going to be expecting to gain $240 from that pile. 20% of that is going to be $60 for that pile. And then 60% of that is going to be negative $1,200. And we see what that makes then. This makes $300 for positive pools and $1,200 loss expectation. This is going to cause your expected value of that to be a loss of $900. So keep that in play for, like, in mind for what you're going to do. I mean, you might make $1,200, you might make $300, you might lose $2,000, and when the weights come in to affect your expected value, that's a big deal. It's not that this is $2,000, that's $1,200. How do the percents, you know, those decimals get in there and make it? This one says expect on average to lose $900, although you won't lose $900. Something will happen to you, and that's what the average of all the expectations would be. Now we go to Jackson Builder. Jackson Builder has a 90% chance that you'll make $3,000. But a 10% chance you'll lose all of it. So this turns out to be the positive expectation here is $2,700. And this 10% chance that you lose that is $400. And when you combine those two, you make an expectation of $2,300. So I would go with Jackson Building. This is not the final decision. Which is the better investment? Based on expected value, it's definitely Jackson Builder, and I would say its expected value is better. Okay. The reason for that is that one is positive, and you're expected to make money if you go with Jackson Builder, because most of the time you will, and when that works out, even though You lose more when you lose than you win when you win. It happens so much more frequently. You wind up making a nice bit of money here. So now the other one, the way it's set up, if you push your $4,000 into there, looks to me like you're expected to lose $900. But you'll never lose all your money. So then some people would say, oh, well then I'm gonna go with the first one because at least I won't lose all my money. I'll have the 2,000 left. Here's my thought on that. Expected value tells you what's going on with the investment. If you don't want to lose your whole $4,000, see if you can get the opportunity to, instead of put your whole $4,000 in, can you put $2,000 into the one with the expected value? Okay? Each of these numbers would be cut in half, and you'd be looking at an expected value there of the return of that being $1,150, and you'd still have your $2,000. That's something else to consider. Don't just look at like, oh boy, I can't afford to lose the $4,000. That's no way I'm going to do that, because maybe there are other options. Expected value is going to have, in all likelihood, the same probabilities locked in, but if you only invest half the money, you'd win half as much and lose half as much, and you'd come out way ahead. And even if the worst case came out on that one, where you lost what would have been $4,000, you only lose the $2,000, and you're still going to have that. But if it goes well for you, you'll get, this $1,500 instead of $3,000. You'll have your original $4,000, and you'll make $1,500. So that's to be advised here too. I can't tell you what to invest in. I can't even guarantee that these will show you how your money's going to turn out. But that's what expected value does. It looks at what you can do with the information you have to give them the weights of their likelihoods and see how they impact as a total package. And if you do this over many, many years, you should come close to your expected value. You shouldn't have losers every year, but you will have some in all likelihood if you do this over many years. So that's what expected value is about, and that's where we are with Home Before.